Last lesson we discussed a little bit about inequalities and some of the different properties that they have. Today we're going to throw one more twist in. We're going to start talking a little bit about absolute value. Now again, absolute value, we always think of it as a positive number, but what we really need to think of it as is that it's a distance. Sometimes you think about distance, as the amount of distance that you're driving. And this is how I always try to remember that it's always going to be positive. When you're driving your car and you drive to your friend's house, it's 10 miles away. When you drive back, does your odometer go back 10? No, it keeps going forward 10. It's a distance. You're moving forward. Same thing going on here. For instance, if we had something asking you the absolute value of x, okay, if our starting point is here at 0, we have two numbers that are 4 away, both positive 4 and negative 4. But the distance, okay, is still 4. So if the absolute value, for instance, of x is 5, then x is 5 or negative 5, because the absolute value of either of those, the distance would be 5 from 0. Well, what happens when we start to throw equations into this? 2x minus 5, the absolute value equals 9. We're going to split it into two equations. The first one, you just leave alone, or maybe we say we just lose the absolute value sign. The second one, what's in the absolute value is the same, but we're going to change the sign of what we're going to call the solution here. That's going to get us that other value that works, and we're going to have to solve both of these. So we're going to add 5 and divide by 2. We're going to add 5 and divide by 2. And we're going to get two solutions, because if I plug these in, 2 times 7 is 12. 2 times 7 is 12. Wow, it's been too long of a day. 2 times 7 is 14, minus 5 is 9. The absolute value of 9 is 9. Plug in the negative 2. 2 times negative 2 is negative 4. Minus 5 is negative 9, but the absolute value of negative 9 is 9. So my two answers work. Okay, that's how equations work. But I said before, we're going to work this into inequalities as well. So as we move up a little bit here, we start to take a peek and we find out, inequalities, must flip sign for a negative number. Okay, depending on what this looks like, if we remember from before, our symbol here, if my absolute value is less than, it's going to be an and statement. We talked about and statements in the last unit as things that we have in common. So in order to achieve this, we're going to do two things. We're going to add another arrow heading to the left. And we're going to switch the sign again of what we call the answer or the solution. You'll notice here those two things I'm talking about. If we just looked at this part, that's basically the same expression we have above, except the absolute value's been disappeared. Now to make it compound, we add another arrow, and you notice the 11 has a negative. Okay, so we've done those two things, and now we just solve the compound inequality. So minus the 7 from all three parts, just like we did in our last section. Divide by 2. And again, we want to make sure all of our values get in. So maybe this time we'll count by 2's. And again, with these, they're typically going to come in towards the middle. So x is greater than negative 9 would be going to the right. X is less than 2 is going to be coming from the left. We color in the middle. Okay. Well, what happens if instead of my absolute value being less than, my absolute value is greater than? Well, as you can see from here, this becomes an or statement. Well, how does that work? Well, just like over here, you'll notice these are the same except my absolute value symbol's gone. But when I move to the second one, what happens? I flip the arrow. And once again, I change the sign of my solution of sorts. Other than that, we're going to do it just the same. So we work on solving both of these. So x is greater than or equal to 3 1/3. So again, we're in the ballpark here. Or equal to makes it a bracket. X is less than or equal to -2. Again, another bracket. Let's do interval notation this time. Starting from the left with negative infinity to the rightmost point at -2. Same symbol we used. Union. We start at 3 1/3 from the left to the right. Okay? But again, the whole key comes from the arrows. Now, could I just separate both of them in a situation like this? Yes. Well, why do I do it two different ways then? Because it helps me to think about what the graph should look like. If I take ands and make them three-part inequalities, they come together, just like the three-part inequalities did in the last section. If I take the or statements and split those when they go opposite directions, it's just like it was in the last section. So we're trying to get some consistency here instead of just saying I only want to think of doing it one way. And the only other thing to think about here is, again, if it comes up as an equation, do it just like we did above. We're going to split it into two. Copy the first time. And the second one, we're just going to change the value of our solution side. Solve both of these for x. Subtract the 10, divide by 4. You're like, now how are you going to graph this? It's just those individual points. So we're just going to put dots on those. And if we were doing interval notation, we would use what's called a brace, and we just would list the individual numbers. Okay? Not parentheses, just a brace. We're going to take a peek at one last problem here on the back side. Take a peek, and you're like, okay, number 3. Let's see, now how'd that go again? Oh yeah, when it's going this way, it's like an or statement, so I'm going to separate them. So I'm going to have negative x plus 5 is greater than 6. So let's keep the first one the way it was. And my second one, I repeat what's on the inside, but what do? I flip the arrow, and I change the sign of my solution on this. So now I'm going to go ahead and solve. Oh yeah, I divided by a negative. I got to flip the arrow. If I don't, I'll get just the opposite of the answer that I'm looking for. And same here, dividing by a negative makes me have to flip them. So just like we did before, x is less than -1. X is greater than 11. And again, interval notation. Left to right for this one. Left to right for my second one with a union in the middle. Good luck with these. We'll talk more in class tomorrow.